Hello everybody, my name is Aiko Duehne. I'm structures expert at EASA, and today I will present you the future European rules on helicopter hoist. To start off, I would like to go back to the history a bit of the hoist and where we started to introduce or to work on new rules for the helicopter hoist. And this was back in 2013 when there was a dummy load lost on a helicopter after some maintenance. Some investigation was done and it was revealed that at least overload clutch failure could not be excluded. And further investigation revealed that there were several issues with this hoist. Based on that, an EASA AD was issued in order to ensure safe operation of the hoist, and a service history was initiated in order to determine whether there were already faults in the past. And based on this, several design deficiencies on the current certified hoist were revealed. I also would like to tell you a bit more about the AD that was introduced. The AD consists of 4 parts. The first part is a periodic overload check that has to be performed on the hoist in order to ensure that the overload clutch is still working as expected. In addition, the time between overhaul was reduced in order to ensure that there is no severe degradation in service. Third is the replacement of the hoist after each slip that occurs in service. And in addition, in order to reduce the loads on the hoist, the operating envelope was reduced, the weight allowed on the hoist was reduced, and the maneuvers the helicopter is allowed to fly was also reduced. In order to enable new hoists on the market and to help the development, it was decided that an hoist ETSO, an European Technical Standard Order, should be drafted and published. To start off, what is an ETSO? An ETSO is a qualification of a part based mostly on an industry standard, so-called on a minimum operational performance standard. This enables a design to be qualified without the rotorcraft, fully independent of the rotorcraft. But it has to be remembered that this ETSO is a standalone piece, and it does not mean that if it is qualified, it is allowed to be fit on a helicopter. Before doing so, a certification project has to be started to certify the integration of the ETSO part, in this case the hoist, to the rotorcraft. Then there is a split between the ETSO holder, because the ETSO holder is responsible exclusively for the ETSO part until the boundary, which is defined in the ETSO, and the installer, who is responsible for the installation from the hoist itself, starting the interface up to the rotorcraft. So a nice thing about this is that the installer does not have to do any substantiation for the hoist, and there's a clear cut between the hoist and the installer, the integrator. So why do we need a hoist ETSO? First of all, the industry wanted an ETSO in order to have the separation between the installation and the hoist itself. The biggest benefit for the industry is that there is a risk sharing between the hoist manufacturer, who is responsible for the hoist and also responsible for the design and the qualification of the hoist, and the integration, which is then on the installer side, but exclusively the installation without looking back at the hoist. An additional advantage is that it also enables an easier entry into market for new hoist manufacturers, because they don't have to have deep knowledge about the rotorcraft itself, for example, flight test, because this is then done by the integrator, and the hoist ETSO holder just has to look at the hoist itself. Another benefit, mostly for the ETSO parts, is that it gives more information than contained in the CS2729 requirements. It's normally based on industry standards, and those industry standards generally go more in detail than the CS2729 does. And the industry also can shape this industry standard to their need so that they can put in the standard the requirements they need for designing a hoist. This Hoist ETSO is based on an industry standard, the SAE standard, which was developed by the working group G26 Helicopter Hoist. This standard calls out for a hoist with an overload protection system, and this working group consisted of manufacturers, OEMs, operators, and authorities. Together, they developed the standard, which was then published in December 2020. Based on this standard, EASA did develop the ETSO. We took the text and had to amend it in several places in order to meet the CS2729 requirements. This is very important that the CS2729 requirements are met, because the installer wants to take the compliance of the hoist for granted. He does not want to look back on the compliance finding of the hoist itself, and only the delta, the installation on the Rotorcraft, will be dealt with by the installer. This NPA was published in August 2021, and the comment period was 2 months. Just a little outlook of what will happen then. These comments will be taken on board. We will review them. We will address every single one. And the ones that are accepted will then change the ETSO. And the changed, updated ETSO, together with the comment response document and the comments provided by EASA, will be then published on our website. So now we want to go a bit more in detail. What is the safety improvement by this ETSO? I think the biggest safety improvement will be the mandatory overload protection device. The overload protection device is there to increase the reaction time of the pilot, mainly in case of an entanglement, in order to give time to assess the situation and do appropriate actions. In addition, it also will limit the energy in the cable in case of a rebound, in case of a cable rupture, and it can also introduce a load shock damping capability, for example, for occupant protection. With this hoist overload protection system, also a dynamic and static slipping point is introduced in order to enable the hoist to reduce the load on the cable already below 3.5 G. This 3.5 G is demanded by the CS2729 requirements. But in order to limit the load as low as possible in service, there is the possibility of having a dynamic reel out of the cable already below 3.5 G. However, at the end, the hoist, including the overload protection system, has to ensure a static holding capability of a minimum of 3.5 G. Also, this overload protection device can be used as a load alleviation device. In addition, also some tests are included in the ETSO in order to ensure that the hoist overload protection system is designed in a robust way. Some other, on the system side, improvements of the new hoist ETSO will be the safety requirements. The hoist will meet the latest safety requirements. That means there will be full redundancy. Single load path will be minimized to the maximum extent possible, and all failures with a catastrophic effect must be extremely improbable. Also, the quick release system is clearly defined, how it works, how it has to be designed, and the reliability and release time requirements are detailed in this ETSO. For the systems, also the environmental standards, mainly the DO160 standard, is defined in a very exact way in order for the hoist manufacturer to know which part of the DO160 has to be used. And for large rotorcraft, the bird strike requirements are introduced already on hoist level so that the hoist manufacturer can provide substantiation against bird strike up to a certain speed decided by the hoist manufacturer. Other important safety improvements of the ETSO, especially on the structure side, is a clear definition of the hoist interface. There's a clear definition where the responsibility of the hoist manufacturer stops and where the responsibility of the installer starts. This makes very clear, also in case of continued airworthiness issues, who is responsible for which part of the hoist installation. We also introduced a paragraph so-called interaction system and structure, which is not so commonly used in the Rotorcraft world, but it already got introduced for the yawing condition. That means that a system which can limit structural loading of, in this case, the hoist system, can take benefit with regards to loads. It is a load alleviation device, and depending on the failure probability of this load alleviation device, certain safety factors have to be used. In addition, the hoist, including the installation, will meet the latest CS 2729 fatigue and damage tolerance requirements. This means that a damage threat assessment has to be performed for the hoist, which is especially important for the cable. And based on this, a full fatigue and damage tolerance analysis has to be done for the entire hoist. Another thing which is introduced on hoist level are the hoist critical parts. Critical parts are already defined for CS 2729 Rotorcraft. It's a part which failure could be catastrophic on Rotorcraft level and has critical characteristic which has to be monitored. In this case, we don't have the Rotorcraft to be critical, but we also want to ensure that no human external cargo is lost. So we defined not only the criticality on Rotorcraft level, but also on hoist level. So this hoist critical parts, it ensures that those parts are manufactured to frozen parameters and that every manufacturing step will be monitored and will be traceable from the raw material up to the final part. Then, in addition, we had to do for the ETSO itself is that we had to align the endurance testing and the fatigue testing so that it is at the end in line with the CS 2729 requirements. For the cable, we also have introduced some specific requirements because the cable is quite a unique part which is in this kind not used anywhere else in the Rotorcraft. We have written the rules in a way that it enables the introduction of synthetic cables. We have precise description of tests in order to ensure that the cable is of a robust design, even if it touches the skids or any sharp edges, rocks, or sharp corners on ships. During service, it should still sustain a certain level of load in order to not risk any loss of heck during operation. In addition, which is especially important for synthetic cables, we defined environmental effects which have to be taken into account, which is, for example, salt water or any fuel, hydraulic liquids, which could contaminate the cable, especially a synthetic cable, and reduce the static and fatigue strength characteristic of this cable. Now, a little global overview of the next generation hoists that hopefully will come in very soon. EASA has been supporting the development of hoist since years, and we are really eager to get new hoists on the market. Currently, there are several hoists under investigation within EASA. We have projects, STC or major change projects. We have several hoists which we are now looking at and hopefully certifying in the near future. Which has to be highlighted is that for new or recently certified helicopters, a next-gen hoist will be mandatory. The legacy hoists, which are now out in the market, will not be able to be installed anymore. Thank you very much for your attention.